Hello, welcome. This is now AQA's AS Physics. This is the Unit 2 June 2009 paper. Okay. This question, I think, obviously is question 5, is very, very difficult purely because you have to, again, it's not really much of a calculation question. It's just testing your knowledge really and being able to apply it. And I don't think personally, if I was doing it that year, I might not have spotted this. Especially, I definitely wouldn't have spotted it straight away, and I'm not even sure I would have got it after looking back through it. Okay, so what I tried to draw here is what's on the exam. Okay, so we've got this direction, we've got this wave. Okay, that's obviously oscillating. It's quite clearly a transverse wave because it's oscillating at right angles to the direction of motion. We've got 2 points here, point X and Y. Okay, we're told there's a distance of 0.5 meters between these 2 points. Okay, and X is on a peak. Okay, and Y is on the node following the next peak. Okay, so what we have to do is take the wavelength of the wave. Now we're not told anything else about this wave. Now you could say, well, we know that the speed of the wave is obviously the speed of light, which is 3 times 10 to the 8 meters per second. Okay, and you could say, well, c equals f lambda, so you could rearrange that. But we don't know the frequency either, so we couldn't do that. Now the only thing that they wouldn't have shown us this diagram in terms of, they wouldn't have put 2 points. Quite clearly 0.5 is not the wavelength. Okay, because we know that the wavelength is peak to peak or trough to trough, and quite clearly the other peak would exist around here. Let's call this position A, for example. Now, we know that obviously the wavelength therefore is less than 0.5 meters, because the wavelength is peak to peak, and it's obviously going to be less than the phase difference. Sorry, I've given it away. Than the difference between X and Y. So X and Y is obviously greater than one wavelength, but that still doesn't help us. Now we need to visualise this, okay? Basically, if we assume this is the start of the wave, and we kind of ignore X for a second, I'll come back to it. I'm going to call this point B, just to confuse you. If you would apply that to X, okay, you would say, well, X is half a phase difference different, so pi on 2 radians out of phase with X, okay? And if we look at, so therefore if we apply this kind of principle to A and X, we'll say A and X are 360 degrees out of phase. In other words, they are in phase, okay? So A and X, this point, that it's not on the diagram, but you might want to label, there's nothing stopping you doing this, that the difference between A and X is 2 pi. Okay, in terms of, that's the difference in the phase difference, okay? So, therefore, because I said the difference between X and B is pi on 2 radians, therefore the distance between A and Y must also be pi on 2 radians. In other words, therefore, if we apply all this together, so the phase difference between X and A was 2 pi radians, and therefore the phase difference between A and Y is pi on 2. So therefore, the phase difference between X and Y is the phase difference between X and A, and the phase difference between A and Y. In other words, it is the phase difference is equal to 2 pi plus pi on 2. In other words, it is 5 pi on 2 out of phase, or 2.5 pi. And obviously, because we know the distance between them, it might have helped you. Yeah, if we know the distance between them and want to find out the wavelength, then obviously what we're going to use is phase difference, because that's the only equation that links to 2. But I tried to build it up in a different way. You should know that phase difference is 2 pi d over lambda, where d is the distance between them and lambda is the wavelength. Now we know the phase difference is 5 pi over 2. So 5 pi over 2 is equal to 2 pi times the distance between them, which we know is 0.5, over lambda. And it's just a case now of rearranging that, okay? So if you were to do that, obviously you would be left with lambda is equal, well, 2 times 0.5 is obviously 1, so it's pi divided by 5 pi over 2. Okay, and it's just a case then of flipping the fraction, okay? So pi times 2 over 5 pi. Okay, so obviously that means therefore the wavelength is equal to 2 pi over 5 pi. Okay, so it's, is that right? So let me double check. So I might have made a stupid mistake there in my calculations. I don't think that's right. So I'm going to just double check. Yeah, that's right. Yeah, sorry, I doubted myself. I thought it was 0.8. Anyway, so we know it's going to be less than 0.5. So these pi's cancel, okay, which means the wavelength, according to our calculations, is 0.4 meters, which is quite substantially. You think that is likely to be correct because it is less than 0.5 meters, which is quite clearly greater than the wavelength because it's greater. It's the distance between x and y is greater than the distance between two peaks of x and a. Okay, so hopefully that makes sense. As I said, I'm not sure of any other way that you would answer that question. Okay, but as I said, if you do have any other ways of getting 0.4 meters that is correct that I've missed out, then please do comment below, and if I forget round to it, I will put your method. Obviously, assuming it's correct. A little sidebar, there'll be like a little text box if there is. Okay, but I don't see any other way of answering that question. Okay, so the next part, the frequency of the wavelength is at 22 Hz. Calculate the speed of the wave. Now I said the speed of the wave was 3. It was the speed of light. Okay. But that's just for, obviously, because we consider wave particle duality, light to be, in terms of, photons is kind of a wavelength, if you can almost imagine wave particle duality kind of thing. So that's why I said the speed of a wave was 3 times 10 to the 8. But that's if you don't know the speed of the wave, that's kind of you assume. But we're told now that the speed of the wave is, we're told that the frequency 22 Hz. So we label what we've got down, as I always do with calculation questions. So the frequency, 22 Hz. We've just calculated the wavelength of 0.4 meters. Now, even if you hadn't got the wavelength to be 0.4 meters, what I would have done at this stage is guess. Well, quite clearly using an estimation, and they might have even got 0.4 purely from just guessing, and then you could have worked backwards. Okay. What I'm saying here is we know that obviously the wavelength is less than 0.5. But it's only marginally less than 0.5. So if you didn't get this 0.4 here for part A, for the first part of part A, you would just say let the wavelength equal whatever, 0.4, 0.3, whatever, okay? And then just use that in your calculation. Now, obviously your answer to A part 2 would be wrong, but the fact that you've shown, they can't take you a mark off, okay? You've already done that. Okay, so we've got F and lambda, well obviously C equals F lambda, so therefore C is equal to 22 Hz times 0.4 meters. And it's just a case then of subbing that into your calculator and getting an answer of 8.8 meters per second. And don't forget the meters per second there. Okay, so that's your A part 2 answer. The next part is to state the phase difference between x and y on string given an appropriate unit. Now this is what makes me think that my calculation of A part 1 was not the right method. And that is because if that was the correct method, we've already said what the phase difference was by just using ideology in terms of, not ideology, just using calculation method. That's why I personally would have shown all of this extra little bit of work in here, and I might have even labelled down, the distance between x and A and x is the wavelength, okay? Maybe not, as I said, it's up to you, but so that's what's made me think that my answer, that this 0.4 meters is completely correct, by the way. There was nothing in my method that I adjusted just so I would get 0.4. So my calculation for A part 1 was completely correct, and it is doable in every sense. Okay, but obviously you can't just put, if you worked it out like that in A part 1, you can't just put, well, we've already calculated it and just state the actual answer that we got, which was 5 pi over 2. Now ideally, because all we're doing now is working backwards now, we work backwards and we're going to work forward through our calculation for A part 1 to get the phase difference. But even if you did what I did for A part 1, you can't just state 5 pi over 2 because it's worth 2 marks. So quite clearly, one of the marks is going to be for some kind of method or working out. So we need to do it as though we hadn't done A part 1 in that sense. Okay, so you can't obviously, it's just a case of going phase difference is 2 pi d over lambda. Well, we know lambda, we know d. So 2 pi times 0.5 over 0.4, which quite clearly gets you 5 pi over 2. Okay? And that would be your phase difference. As I said, that's why I wouldn't just state 5 pi over 2. I would do that calculation. Because if you get a mark for the calculation and a mark for the answer. Okay? So that's the answer to A part 3. Describe how the displacement, so 5b is just kind of an explanation, so I'm not going to write anything down for it, but I might give you some pointers into what it says on the mark scheme. No, there's no real pointers. You just need to say, well, how would it oscillate, okay? So point-wise, this point of no displacement, you just go, well, over the next half period, so half time period, so we just go, well, what is the time period? Peak to peak, trough to trough. Okay, so it's the peak to trough, okay, and that's the halfway length. So you go maximum displacement, no displacement, and then it goes to maximum displacement again. Okay, and obviously, okay, so as I said, the answers for 5b are online, and it might give a better indication than I've done, but as I said, hopefully that made some kind of sense. So the main part of this was really the A parts, really that was the more confusing bit. And as I said before, if you have any other ways of calculating A part 1, which I really don't think my way of working it was right. The method was completely correct, and in every sense the fact that, you know, there was no calculations that were wrong, there was nothing that I did that was deemed to be illegal, in the sense that, you know, just put numbers from thin air and made it work. But it's just the fact that part A part 3, asked that question to work out the phase difference, that made me go, well, was that really the way of working out? Was there another way that I didn't show? Okay, so please, as I said, if you've got any ideas, let me know or comment on the answer. Hopefully, we'll see you in the next question, and thanks for watching.